monolithic applications. So monolithic applications are the application which we normally see in our real-time scenario, right? So basically you have one application and that will be doing all the kind of processing. Okay, let's take you have an e-commerce application which basically receives a request, and there you will have a list all the products, and user can log in and they can buy a product, and using a payment gateway they will be the payment will be made, and after that the instructions will be given to a shipping company which will ship the product to the end user. Okay, this is one of the application. Like that we have n number of applications like HRMS, CRM. Okay, huge set of applications. Okay, so for our easier understanding, let's take an example of a internet banking application. Okay, so in internet banking, what are the services we normally do is like we will be checking the current balance of your account. Okay, or you will be transferring some funds to the other account using fund transfer option, and you will have a reporting service where you will be creating a report of last n transactions or the past month. If you want to see all the transactions, you can do it. And adding to that, you will have multiple other services, like if you want to request for a checkbook, you can do it, or if you want to change your address, you are allowed to do it. If you want to make a FD, you can do it. Okay, so normally you will have one application which will be storing a data in the database. Okay, and this application may have two layers. One may be your web layer through which you will be communicating, and there will be some business logic layer, right, which will be processing the data and doing things. And finally, either the data will be shown to you from the database or the data will be stored in the database. Okay. So this is a typical example of a monolithic application. Okay, but there are a couple of problems in this application. Okay, the first and foremost problem I'm going to highlight is called scaling. Okay, so when I talk about scaling application, there are two kinds of scaling available. Okay, so vertical scaling is something like on a server. Let's say the server is having 4 CPU and 16 GB RAM. Okay, so vertical scaling means you are going to increase the capacity of the server. Like for example, I'm going to add additional RAM to the server. Okay, on a virtual environment, you are going to change the instance type. Okay, so there it will get a additional CPU and then additional memory. Okay, but there is a problem in the vertical scaling that is called as there is a limitation in the vertical scaling. Let me take an example of a physical machine. So you will not be able to increase the number of CPU beyond a particular limit. Okay, and in the same way, based on the RAM slot available on the machine, you will not be able to increase the RAM also. Okay, so in that case, you will not be able to scale the server beyond a particular limit. That is where the horizontal scaling comes into picture. So horizontal scaling is something you are going to put a additional server. Okay, a copy of the application will be put in there, and you will put a load balancer in front of these two servers, and that load balancer will be sharing the data to these servers. So in load balancer, there are different types of mechanism in which the request will be forwarded to the target servers. Okay, let's say I have two servers. We call it as server A and then server B. Okay, so there is one routing option available in load balancer. It's called round robin load balancing. That means the first request will be sent to the server A, and second request will be sent to server B, and it will be keep on repeated. So this concept is called round robin routing. The next option available in the routing is called as a weighted method. So I can say that send 75% of the request to server A and 25% of this request to server B. Then 3 requests will be sent to server A, and there will be only 1 request that will be sent to the server B. So these are all the different types of routing available in the load balancers. In load balancers also, there are 2 kinds of load balancers available. Okay, one is called as a layer 4 load balancing. So this is which I talked about right now. So any request comes in, it will just send the data to the target server. So the reason why I'm saying this is a layer 4 load balancing in the OSI model of networking, so we have 7 layers, right? So the first layer is physical layer, second layer is data link layer, third layer is network layer, the fourth layer is transport layer. So in the transport layer, the packets will be transferred to the target server. Okay. And the next layer is session layer, and the next layer is presentation layer, and the final 7th layer is called as application layer. Okay. The 7th layer in the OSI model is called as your application layer. So the limitation with the 4th layer of load balancing is based on the request, I will not be able to do any custom routing. Like for example, I want to have a load balancer which should read the content or the URL in which they are requesting, and based on that, the request has to be transferred to a different application. Let's say if I call www.training.com/HR, it should take me to the HR application. If it should like /finance, it should take me to the finance application. So that is not possible in the layer 7 load balancing. That is where, layer 4 load balancing, it is not possible. That is where the layer 7 load balancing comes into picture. So the layer 7 load balancer can read the data, and based on the data, it can redirect the traffic. Okay. So this concept is called as a application load balancing. Okay. So these are all the 7 layers I have talked about. Okay. So when a packet is getting transferred from one machine to another machine, okay, so it will start with the 7th layer. So when you in the browser, if you are going to type in like www.google.com, so that is your 7th layer. Okay. So there you will be seeing the end user, like the URL will be visible only on this layer. Okay. So when you type it on the browser, it is going to convert it into a HTTP request. Okay. So it will convert them into a programming language request. That is what happened in the presentation layer. Okay. And then in the session layer, it is going to make a session with the server. So as of now, there is no session managed. So it will have the mentioned the source IP. Yesterday we talked about the NATing and all those stuff, right? So all those information will get appended there. Okay. Then in the transport layer, this is where the target IP definition, all those things are getting created. So what should be my target IP and how the communication should happen? What should be the route I should be taking? So that is what will happen in the transport layer. Then that particular request with the source IP, target IP, what is the route I'm going to take? All those things will be divided into packets. So the actual data will be divided into small packets, and that packets will be converted into frames. That means, so in the OS level, the packet will be transformed as a electrical signals in your Ethernet card. Okay, if you are using a fiber optics, it will be transformed into a light signal. Okay, then these electrical signals or the light signals will be sent to the physical layer. Once the data reaches the google.com, it will reach as an electrical or light signal here. Then it will be converted into a frames here, and the frames will be converted into packets. Okay, from the frames, it will be converted into packets, and from the packet, the end-to-end information, that is, what is my target IP? Okay, once the packet reaches the router in google.com, it reads what is my target IP. Okay, my target IP is google.com, so I should send it to the Google web server. Okay, then it will talk about the session. So this user is already having a session with this, so I need to take it to the respective server. Okay, then from the session, it goes to the presentation layer where the data will be converted into a HTTP request, and then that HTTP file will be displayed on your application layer. So the complete data will be available only on the application layer. So that's why the layer 7 load balancer works on this layer, where it will not be able to read the content of the request. So that is the reason in layer 4 load balancing, you will not be able to read the content of the request. So you will not be able to transfer. So in the layer 4, any request come to the target IP, it will be pushed to the target IP. That's it, nothing else. But If the load balancer is working on the layer 7, it will be able to read the request, and based on the request, you can take some decision. That's what it is called as a layer 7 load balancing or application load balancing. So I can put a load balancer and I can copy the application as two different servers. So the first request, instead of one server processing the request, I will have now two server processing the request. So I will get a better performance on it. Okay. So this is what is called as a scaling. Okay. So the problem in the scaling on the monolithic scenario is, let's say this application needs 8 CPU and then 16 GB RAM to host the application. When I want to scale up the application, I need to bring up another server with a similar configuration. I need a server with 8 CPU and then 16 GB RAM. Okay, but my real demand may not be the same thing. Okay, and basically that resources are going to use to run the other application also. Imagine on the first week of the month, I normally get more requests on the check balance and fund transfer. I don't need any resources for the other related services, right? For reporting and other things may not have a much load on the first week of a month, right? So in this case, the scaling, what I'm doing is unnecessarily I'm scaling other components which are not in use. Okay. At the same time, as this application is kind of a huge application, it will take a longer time to bring up the application. Like for example, the server itself will take at least 3 to 4 minutes to bring up the server. And after that, you will, the application will take at least 2 to 3 minutes to come up the application. So a real-time scaling, it will take at least 10 minutes to add the server to the load balancer and start processing the request. Okay. But the problem with this is, okay, hope you are imagined, you guys might have known about the Flipkart's first Big Billion Day sale, where they were not able to scale up to the demand of the customers. So because of that, they got a very bad name with the customers. Like at the time, the products were available very cheaper, but no one was able to order it because of the huge demand. So they were not able to immediately scale up the application, and that is because of the monolithic nature of the application. Okay. This is the first problem in the scaling. So you will be unnecessarily scaling the application. At the same time, you will be also, you will not be able to scale up the application in a faster manner. This is the first problem with the monolithic. And next problem is making changes to the application. Okay, imagine this net banking application doesn't have a IMPS functionality. Okay, so imagine the team who developed the application is no longer available. I'm going to build a new team who will be implementing the IMPS functionality into that. So in that case, that team has to go through the complete code, the documentation, whatever they have, and then the complete code to understand where exactly I need to make the changes. Let's say the application is having some 50,000 lines of code. So it will take a longer time for the new team to understand the application. Okay. And even after understanding the application, it will take a long time for them to test the application, right? Because I need to, when I make the changes, I need to ensure that this changes is not impacting other functionalities of the application. So I need to have a longer QA cycle. I need to go for a regression testing, all those things. It's going to take a more time to make or implement changes into this application. This is another problem. So the first issue is on the scaling, and the second issue is on the changes to the application. Okay. And the next issue is, imagine you are developed the application on a technology, right? Let's say I'm at the time when I developed, like 5 years before, Java 7 was extremely used. I used the application Java 7. Okay. So I want to move into the latest technologies like Node or Python or something like that. Okay. I will not be able to really do that, because if I think about rewriting the application, it's a humongous process for me. I will not be able to rewrite the application, and I have to live with the technology what I choose before 5 years. I need to live with that until unless this application become obsolete and then I have to move into the new technology. Okay, so this is going to be a problem for me. So you need to have a long-term commitments to your technology stack. Okay, and another problem with this monolithic application is, imagine I have made some changes to the fund transfer application where I have implemented the IMPS. While deploying, some bug has came in. Because of that, it tend to bring down the complete application. Okay, when there is an issue in the code, it is going to bring down the complete application instead of that particular functionality. So in that case, what happens? There was an issue only on the fund transfer application, but my complete application got impacted. So the risk of failure is higher on the monolithic application. This kind of risk also increases the number of deployments on the application. So as the risk is higher, you need to get lots of approvals, lots of testing needs to be done. So the changes will take a longer time to. So this is the disadvantage. Okay, so obstacle to a few frequent development. Okay, if I don't have frequent developments, I will not have more functionalities into the application, right? So literally the functionalities, implementation of new functionalities, it's going to take a longer time. Okay, and the next thing is you need to redeploy the complete application, okay, to change only one component, right? So when I want to make changes only to the fund transfer application, I need to redeploy the complete application, rebuild it and do it. So this is going to take a longer time for me to do. And this, it interrupts long running background jobs. Like imagine when I'm doing deployment on this application, okay, it interrupts long running background jobs. Like imagine when I'm doing deployment on this application, okay, this is going to impact my reporting jobs. Okay, when I'm doing the deployment, there will not be the reporting jobs or day-to-day OLTP to OLAP conversion jobs. Those kind of jobs cannot run at that time. Okay, so this is another disadvantage, and increase the risk of failure because one change may impact multiple, may impact the complete application. Okay, and updates will happen very less often. Okay, because it has a huge QO cycles. Okay, and as the application is huge, your ID is going to get overloaded and also your containers. So it will take a lot. It will reduce the efficiency of a developer to work towards that. Okay, and so you cannot scale the development also. Okay, it will take the new team longer time for the new team to come and learn the code and then understand and start the development. Okay, and then conflicting resource requirement, and as I told you, requires long-term commitment to a technology stack, and you will have a scaling issue. Okay, so instead of living with these issues, if I convert my application into a microservice based scenario, like let's say I'm going to have a check balance application as a separate service, fund transfer as a separate service, report as a separate service, and other services are going to run as a separate service, and I'm exposing to the external world via some common API gateway, and I'm going to write it on a single database. Let's keep that way. This is not a ideal microservice scenario, but let's say you are having using a common database. Okay, in that case, if I want to scale the application, okay, so previously I need 8 CPU and then 16 GB RAM to scale the application. Now, let's say if my check balance needs only 2 CPU and 4 GB RAM to run, I can just scale up the particular required component with a lesser resource constraint. Like I just need 2 CPU and 4 GB RAM to scale up the check balance application. Yeah, and application will not be heavy, so the application will come up very fast. Within seconds, I can do the auto scaling. So my auto scaling will be much faster compared to the monolithic scenario. Okay, so these are all the advantages on the scaling part when we use a microservice based architecture. Okay, so the previous another advantage you are going to get is your development cycles are going to be much faster. Okay, so the advantage here it is, imagine the same scenario where in the fund transfer application or in the fund transfer service, I am going to implement IMPS. Let's keep the same change. Okay. So imagine this code is having only 5,000 lines of code. So for the new team to understand the 5,000 lines of code, which will be much faster compared to the 50,000 lines of code. Okay. And this is going to help me to bring up the speed up the development process. Okay. And another thing is, while doing the deployment, if in case the new deployment brought in a bug, if the service is getting impacted, only the fund transfer application will become unavailable. All the other services will be available. So it is going to increase my availability of my overall application. Even if there is any issue, the issue will be isolated within the service. Okay. So this is the advantage I'm going to get when I have it as a microservice based scenario. So I will be able to isolate the failures and I will have a faster deployment. Okay. And another advantage is I may not need to do the complete application testing. On a worst case scenario, you can do a automated testing, which will be much faster, as you can run the testings in a parallel way. So I'm making some changes to one part of the service. So I just need to test the particular service and then I will be able to deploy the application. Okay. And another thing is, you don't need to deploy the complete application. Only you need to create a new deployment for the fund transfer, because that is an independent service without impacting the other service. So these are all the advantages you are going to get if you implement microservices. So first is you will have a faster development and you will have the isolation of failures, and scalability is going to be much more faster. Okay. And then life cycle automation, as these are small components, you will be able to automate them. Okay. And at the same time, it will be relational with the business service what the particular application is providing. Okay. So these are all the advantages of going into microservices. So coming back to the benefits, faster development, isolation and resiliation, and scalability will be much faster, and it takes fewer resources, and lifecycle automation. So as these are small components, you will be able to automatically deploy them, automated testing environment and all those things, and relationship to the business. Okay. So when you are converting a monolithic application to microservice application, okay, it is always advised to convert the application in the business context, not in the technology or stack context. Like for example, if you're having application, it's not a best practice to convert the application into microservice, saying that, okay, I will have web layer as a separate service, app layer as a separate service, DB layer as a separate service. That is not the right way of decoupling a monolithic application. It should be divided into multiple business process. Like for example, in the e-commerce side, let's take, you will have a customer management where the customers are managed, and you will have an order management which takes care of receiving the order and then placing the order, and you will have a payment gateway, so which basically takes care of giving the payment gateway URL to the end user. They fill in the card details or bank details, and it goes to a third party. From there it gets to it. Okay, that is a separate business unit. And you will have an inventory management or catalog management as a separate business unit. So for that, you have to create a separate service. Okay. And in microservice world, a service should be a full stack application. That means it should have the UI layer. It also should have the business logic layer. It also should have a database layer. All these three should be combined and called as a service. So you cannot call just the UI layer as a microservice. Whenever you are defining a microservice, it should have all the three layers. That means it should be a full stack application. You can call it as a service. So you will be able to relate the business units with the microservice segregation. So this is the another advantage you are going to get when going for the microservice based implementation. Because of the multiple service concept, microservice also has some disadvantages. Okay. So the first and foremost thing will be, complexity. It is going to make your application look very complex. Okay. Currently, you are managing the application. You will have one web server, one application server, and one database server. Okay. But when you are converting them into, let's say, on an average, you are converting one application into 15 microservices, you will end up in managing 15 web containers, 15 business logic containers, and 15, not necessarily 15, at least minimum of some 7 to 8 database containers. Okay. This is going to make your application very, very complex. Okay. That is one biggest problem it is going to come in. And next is the initial implementation is going to be a trouble for you. So when you are decoupling the architecture, so you need to ensure that it is working fine. Like this component is having communication with that. And there you may have to come up with a scenario that one service can talk to another one, like the service A can talk to service B, but it should not talk to service C. Those kind of limitations will also come into picture. So you will have a pretty complex nature, and also managing those services is going to become a big trouble for you. Like instead of managing 3 servers, you end up in managing almost 50 to 60 containers. Okay, that is a problem for you. But luckily, we have container orchestration platforms like Kubernetes or OpenShift. Okay, they can help you to automate some of the process. Like they will help you to automate the deployment. Okay, they will help you to manage the application. If one particular service goes down, okay, it can automatically bring it up. Okay, so those kind of things it can do it. But the initial complexity in the deployment, that you have to live with it. But once you deploy the application, managing the applications are going to be much, much easier. Okay, so only problem I would say in the microservices, because of the tools availability, the only problem you would see is the complexity is increasing in the application. But if you cross the phase of initial deployment, managing these applications are going to be much, much easier and faster. Let's talk about the characteristics of a microservice. Okay, when I can call a service as a microservice. Okay, so I need to define a characteristics, right? So when I say something is a, when I'm giving it as a name, I need to say this is the characteristics. If the particular thing matches this characteristics, I can call this as a microservice. Okay, so the first characteristics of a microservice that is that it should be small. But small is a very, very relative thing, right? So if you see that a smaller user authentication application may look small when compared to a core banking application, right? So a core banking application may look smaller when we talk about the e-commerce, multi-region e-commerce application. So small is a relatively, it's a very relative term. Okay. So to define it correctly, okay. So a service can be called as a small when the changes to the application or rewriting the application can be done within 2 sprints in Agile. You can call this as a smaller application. Okay, this is one kind of higher level definition. So if you will be able to rewrite the application in a 2 sprints, 2 Agile sprints, then you can call this as a smaller application. Characteristics of application, it should be stateless. That means this application should not be dependent on the other thing. Okay, so whatever information which is needed to process the request, like for example, I am giving an order management. Let's take an e-commerce situation. So there I'm going to talk about the order management system. So the order management system will be like for the order management system, I'm going to say, I'm the customer, I want this product. Okay, so the product information will be provided and the customer information will be provided. Okay, it should be able to process the order and take me to the payment gateway. Okay, and in the order processing system, I may also have some business logic. We'll come and talk about that. So it will have a separate thing. So if a request is given to the service, it should be individually able to process the request within, and if it needs some additional information, it can communicate to the other system and get the information. Like for example, the order management can communicate to the inventory system and see that whether the product is really available, then it can confirm the order processing. So it should be stateless. Okay, it should not be dependent on any other system. Okay, and it should be able to service the request without remembering the previous state. Okay, so this customer has ordered some previous thing, so those kind of dependencies should not be there. So this is the example of a stateless application. The next characteristics of a microservice is called as independent or interdependent. Okay, so independent means the service can consume information from the other service, but it should have its, if there is any business logic needs to be applied, it should be available on the service itself. Okay, so I will give you an example of the independence. So imagine currently there is lockdown happening across India. So if you see that in India, some states are having lockdown, some states are not having lockdown. Let's say I'm going to Amazon.com. I'm in Chennai. In Chennai, due to the lockdown, what is happening is only essential services are allowed to order in Amazon. Non-essential services are not allowed. Okay, in the order. So in that case, in the order management system, based on the PIN code of the user, okay, let's say the delivery has to happen on Chennai, so it's normally starts with 6,000. So if based on the PIN code of the user, it should take a logic saying there is a lockdown in Chennai, so a non-essential service cannot be delivered at this time. So it should say that your product cannot be delivered. So the logic is written well within the order management system. So it is not going to go to the other service and get that apply this business logic and come back and display it here. This should not be the case. Okay, any business logic which are required for the particular service to be processed, which should be internal to the service itself. In the same case, if it is Hyderabad, I should be able to I should allow the user to place the order. Okay, so this is the advantage, or this is one of the important characteristics of a microservice. So it should be independent, but it can receive inputs from the other services. Like to get the customer PIN code number, it may have to connect to the customer management service. Okay, so these are all the another important characteristics of a microservice. And the last but not least, it should be a full stack application. Okay, it should have a UI layer or a API layer to receive and send request. Okay, and it should have a business logic layer to process the logic, and it should have a database layer to store the data. Okay, so these are all the 4 important characteristics of a microservice. It should be small, stateless, independent, and it should be a full stack application.